What is up, YouTube? Welcome back to another episode on Code with Annie. And in this episode, we're going to continue with what we left off in the last one, which was explanation of how you can create your own custom data structures. So last episode, we saw how we can create a node class, and a node class is basically the class which holds a data, a pointer to the next node and a pointer to the previous node. This is for building a linked list data structure. So this is one of the first fundamental steps they need to do. And we observed that how we can create this node class and using generics. In this video, we're going to see how we can create our own array list. So I've created one here called as my list. So let me explain you how this one works. Okay. So my list is nothing but a list implementation that I'm trying to do myself. So I'm not implementing the list interface for your reference. I'm just creating a class called my list. And this is the custom list class which I've created. Now what I'm trying to do here is I have three methods in this class. Okay. One is add, one is remove, and one is print list. Add is going to add elements to the end of the list. Remove is going to help you remove elements from anywhere in the list, whether the first element or anywhere in the middle or the last element. Print list is going to iterate over the list and print out the elements in that list. Okay. All of these operate on the node class, which I have created in the last episode I showed you. Okay. So all of them operate on the node class. And initially what I'm doing is I have two variables here, head and temp head. So what these two represent is the head, which is the starting point, is null, and temp head is also null. And temp head is basically a tracking pointer. What I mean by tracking pointer is when you do operations like add, remove, or print, right, you will have to iterate through the elements one by one, right? So as you go to each element, the temp head will take the value of that particular position and it will be able to print out the value for that. Temp head is basically the one that tracks the entire list for us, and it is always assigned initially as the head. And at the end of each operation here, be it add or remove or print list, after you have completed the operation, temp head will again point back to the head. So in a sense, what I'm trying to do is once I have the head node in place, I don't want to move away from it because this is the starting point for my list. I'll use temp head to move around and play in the list. Okay. And temp head, after I've done playing, will point back to the head with whatever value head was assigned. Right now, initially it's null. So the moment I say add, let's expand this function, and we see the first condition we check is if head is null, which means this is the first element that I'm going to add to my list. What I will do is I will say let the head be equal to the node that I want to create. So this node is something that I pass to the add function, and temp head is also going to point to head. So temp head is also going to be node. So both of them are now not null. They are now pointing to node, and I'll return immediately because I don't want to proceed with the code. I have just added my first element to the list. Subsequently, when I add another element, let's say when I add one more element to it, head will not be null because now head is being assigned with node, right? So the second node that comes in here will go into this condition. This condition will not execute. It will fail because head is not null. It will see temp head dot next. So what is temp head dot next? Whatever is the element after head, because temp head and head are same. Remember that. So temp head dot next is going to be the element next to temp head. If that is not null, in our case that is also null because we only have one element. The next is null. So this condition is not satisfied. The while will not enter. It will come down. It will see temp head dot next is equal to node. So what I'm trying to assign is I know the temp head dot next is null. Therefore, I'm now saying now temp head is dot next will not be null. It will be the new node, the second element, and the node's previous element, node dot previous. We observe two pointers here, right? Next and previous. So I'm populating that. I'm saying that the node dot previous is going to be temp head. So I'm doing the bi-linkage between the node and head. So there is head and then there is a new element now. And the new element is the element that comes when you say temp head dot next, basically head dot next. And the new element's previous element is nothing but the temp head. So once I've done with this playing around, I assign back temp head to head, meaning I go back to the first root element, which is the head. Okay. If you have understood this, it's little bit, it might look a little bit tricky in the beginning, but you can watch this video again. You will be able to grasp the idea of what I'm trying to explain. The last use case for this add is basically when you see that you have one element, you have second element also in place. Then when you add the third element, temp head dot next will not be equal to null because temp head dot next will point to the second node. Head is already there, second node is there, you want to add third node. Then you will say, go ahead and find the next element, temp head.next. Assign temp head is equal to temp head.next. Basically, I'm moving the temp head, I'm going iterating one by one. I'm saying that, okay, if there is head pointing to node 1, pointing to, now I want to insert node 2. So I say that initially temp head.next is head is temp head, right? So you have already reassigned it. So once it's not null, I'm saying what is head.next? Head.next is node 1. So I go to node 1. I say that temp head is now node 1. Now again, I see that this dot next is not equal to null. It is null. So after node 1, there is nothing there. Then it will come out of the while loop. So what I'm trying to do is, if I have elements like this all the way, okay, I'll keep going until I reach the last element here, which is node 3. So till then, because node 3.next will be null, right? So until then, it will keep on iterating. It will go on incrementing the next, and it will keep on going. So next is basically the way to reach from one node to another node. So once I reach node 3, which is, as I mentioned, right, add operation is going to add elements to the last tail of the list, right? So once it reaches the last point, it will say that it will execute this operation, which is basically assigning node 3.next is equal to the new element. A new element dot previous will be equal to node 3 in our case, and then again temp head is sitting here, right? Temp head is node 3 now. So temp head again goes all the way back to head, right? So this operation will help you insert the elements. Now this is the add operation. Now likewise for the remove operation as well, right? You check initially if temp head.next, you give a node to remove from the list. Now this node can be anywhere in the list. It can be the first element, it can be anywhere in the middle, or it could be the last element. So what I'm checking is, while temp head.next not equal to null, okay, if temp head.data is equal to node.data, okay, so until I start iteration, I see that suppose I start at the first element. I'll always start at the first element. So I'll say that first element dot next is not equal to null. That means the list has more than one element. Okay. Then go ahead and see if that particular data is the data that I want to delete. The temp head data is the data I want to delete. Head data is what I want to delete. If it is, then I check that if temp head dot previous is equal to null. What I intend to do by this check is, you remember head is a starting point. So anything previous to head is null. So if my temp head dot previous is null, it means this is the starting point and I'm going to remove the head of the list. So what I say is head is going to be whatever is next to the head, which is temp head dot next. That will become the new head, and temp head will again point to that new head that I just assigned, and I'll return out of this. Very clever assignment. What I'm trying to do is, I know that head is the element I want to remove. So head, now the next element to head, second element becomes the head, and temp head will now track the second element, which is now the new head, and we just return. That's it. So with this, we have removed the first element. In case if this is not true, which means this element is somewhere in the middle that I'm trying to remove, okay, then what I'll do is I'll say that temp head dot previous dot next. So what I'm trying to do here is the element, let's say I have something like this. Node 1 is 1, node head is 1, then we have 2, then we have 3, then we have 4. Now I want to remove 3. What I am intending to do is, suppose this is the element that I want to remove, and temp head is now pointing to 3. I'm saying temp head dot previous, which is 2 dot next is actually 3, right? So temp head dot previous, which is basically 2 dot next is going to point to temp head dot next, which is 4. What I'm trying to do is I'm going to disconnect this connection and make 2 point to 4. In essence, what I'm doing is 1, 2, and then make 2 point to 4 with this line. And also what I'm saying is temp head dot next dot previous, which is temp head dot next was 3, right? Now 3 dot next is 4, and 4 dot previous was already pointing to 3. Now I am changing that also to point to 2. I have to make the two-way connection. Remember, I need to make 2 point to 4 and 4 point to 2 because this is a doubly linked list. It has to track back on its own. So 2 points to 4 and 4 points to 2. That is exactly what these two lines will accomplish for me, and 3 will be out of the picture. This is the end result that I'll expect. And once I'm done with that, my temp head has finished its duty. It will go all the way back to 1. So temp head equal to head, return. All right. So this is the remove function. And then finally, so until this condition is satisfied, I will keep going. So if at all, for example, I'm going to remove 4, then this condition will keep going until I reach 4, and when I reach 4, I know the temp.next is equal to null. So this condition while loop will break. It will come all the way to this point. This means this is the last element I'm going to remove. So what I do here is I say that temp_head.data is equal to node.data. I'm just checking if 4, that is the last element, is the element that I want to remove, that I have passed here. If it is, well and good, then what you do is temp_head.previous.next is equal to null. Basically just remove it. So temp_head.previous was 3. Now 3 will point to null, meaning after 3 there's null. There's nothing here. List ends. Okay, once I'm done with this job, I will again assign temp head to head. Remember, I'm doing it 2 times here, temp head to head here, because 3 times actually. Once here because this is the first element criteria head node. So once removed, I'll just return. And before return, I want to move back my pointer to the beginning. Suppose this is not satisfied and this gets satisfied, again I will have to do temp head.head and then return, because I need to move the pointer back. Likewise, if this entire while loop is not satisfied till the next becomes null and nothing has executed because we have reached the last element, then again I will do temp head equal to head. If this is quite clear, then we will go ahead with the next operation, which is print list. So I ideally put the comments there. You can pause the video and try to write this code by yourself to understand how this is working. The last one is print list, which is very simple. All I'm trying to do is I'll start with my temp head, because every time, every operation completion, I'm assigning head back to temp head back to head, right? So always it's going to start with the first element. So temp head is not null. Keep on printing the data in temp head and then keep moving one by one. So 1, 2, 3, 4 until that head becomes null, meaning I've reached the last, end of the list. Beyond 4, for example, if there is only 1, 2, 3, 4, right? So all this will do is 1 is not null, 2 is not null, 3 is not null, 4 is not null. After 4.next is going to be null. So this will satisfy, will come out of the loop, and then finally, as usual, because I've reached all the way to the last and temp head becomes null, I have to reassign it back to head, which is temp head dot equal to head. So this simple technique will help you build 3 functions for you: add, remove, and print list. And voila, you have a functioning list for yourself. We can test this out as well with some of the examples here. I did comment this out, so I'll just uncomment it. Oh, this is multi-line comment, sorry. So let's see. Okay, this is node.java, sorry, my bad. Main.java is here, right? So let's see. This is the thing I tried to run. So all I'm trying to do here is, let me import the classes first. The node is important. Let's import it. Imported the node. Node has been imported. My list has to be imported. My list has imported. Everything is there. So what I'm trying to do is I'm going to create a head node, which is 10. So last starting of my list is 10. 10, 20, 30, 40, 50 are the 5 elements I've created here. So starting from head, node 1, node 2, node 3, I'm going to add all of them into my list. I just created an object for that. I said list.add head, list.add node 1, list.add node 2, list.add node 3. So the add operation will make sure that I sequence these elements one by one as I expect it to sequence it. And once this is done, I'm going to print out the list. Then I'm going to remove the head, again print the list. Then I'm going to remove something in the middle, print the list. Then I'm going to remove the head. Okay, node 1 is not the head. Node 1 is the second element in the list. I'm going to remove that, print the list, and remove the last element in the list and print the list. Again, remove the head, print the list, and then add one more element and print the list. Let's see how this pans out with this implementation. Let me run this one and show you what happens. And hope it works, because I think it should work, because I already wrote this code. But the reason why I took my time to explain this and not type it along with you guys, because this would stretch the video. That is reason number 1. Reason number 2 is it will sound very confusing when I start typing it, because once I do that, you might get a little more confused and probably lose interest. So I had to go slowly and explain. So initially we see 10, 20, 30, 40, all the elements that we initially had. Okay. So I just added till node 3, right? Make a note of that. I didn't add node 4. So I did 10, 20, 30, 40, and I removed node 1, which is basically 20, because head is 10, node 1 is 20. So I removed that. I got 10, 30, 40. Then what I did is I printed the list again. You saw that 10, 30, 40. Then I removed node 3, which is basically the last one I inserted, which is 40. And you can see 10 and 30 only printing out here, right? Then after that, I removed the head, which is 10. And now only 30 was remaining after that. Then I added the node 4, which was 50. And now you can see 30 and 50. And just like that, you've created your own list implementation. So like this, you can create your own implementations for map, for cube, if you want. So all of them will use this basic constant. You have to understand, very importantly, how you can emulate those functions, because add, remove, and print, right? These are basic functions which you can emulate for any data structure. Okay. And you need to keep in mind this node class is going to be the most important one, because this is the one on which you will perform the operations. And this is just for the list I've showed you. Likewise, you can do the same thing for a map, for a queue, everything you can do that. That is up to your imagination. If you could understand those data structures really well, you can create your own data structures like this. Some of these are actually interview questions where people ask you to create your own data structure, and this is how you do it. This is just one example. If you like this video, hit the like button, subscribe to Code with Ani if you haven't already. If this stretched beyond 10 minutes, I apologize, but this needed a detailed explanation. Watch this video again if you want to, but if you want to get more clarity, do subscribe to Code with Ani, and I'll bring more such awesome content to you guys. See you guys in the next one. Bye-bye.